Okay, welcome to Class TV. I name myself Alevi Tosin. We are on electricity part 5. This time we are taking electromotive force. What is electromotive force? Electromotive force is the potential difference between the terminals of a cell when no current is flowing through it. Electromotive force, like I said, is the potential difference between the terminals of a cell when no current is flowing through it. In our previous class, we discussed about what potential difference is. We said, if you could remember, that potential difference is the work done in moving a unit mass of charge from one point to another, mostly from higher potential to what? Lower potential. Now, this time around, we said electromotive cell, which is called EMF, refers to the potential difference between the terminals of a cell when no current is flowing through it. Now, this is a typical example. We are having this as our resistance. This is resistor. Now, we have this kind of sign used for resistor for a variable resistor. If you remember, we have this as what? A standard resistor, and we have this sign, this symbol as what? Variable resistor, or we also use this as to symbolize your variable resistor. We have the flow of current here, and this we have what? Our cell, that's the battery here. Now, we call this the what? The external resistor. Why we call this what? The internal resistor. We say our R is the external resistor and our small r is the what? Internal resistor. So we say that our electromotive force is denoted by E. It is denoted by E, and it is measured in volts. It is measured in what? Measured in volts. That's what it is measured in volts, just like the potential difference. Now we say it is given as E from E is equals to, that's from our Ohm's law, when we say that V is equals to Ri. From there we can say that our V is the potential difference. In this case now, our V, when current is not flowing through the circuit, our potential difference now is E, which is what? Electromotive force. From when we said V is equals to Ri, our V here is the electromotive force. Our R now, we are having two R's here, which is what? The external resistor and the what? Internal resistance. And you have I, this is the what? This is the I. So we can say that what? From V is equal to R now, you can say this E here is our potential difference, which we said this one too, our I remains the I, and this our external resistance plus what? Internal resistance is what? Our big R. Is that taken? So from this now, we can say that what? Our I divide through our I now could be given written as what? E over R plus R. So where our E is the EMF of the cell, and we have our R as the what? External resistance. And we have the small r as the what? Internal resistance. So that gives you what? Our electromotive force. Alright, now let's take something else. Now let's take this example. An electric cell of internal resistance is 0.5 ohms delivers a current of 2.0 amperes when resistance of 3 ohms is connected across it. Find the electromotive force. Now, the givens here, we are given our I, which is the current, as 2.0 ampere. We are given the internal resistance, small r, as 0.5 amperes. And we are given the external resistance, big R, as 0.5 ohms, and 3 ohms. So we are told to find the what? The electromotive force. For this now, we say that our electromotive force equals to I into bracket R plus small r. So our E here, which is the electromotive force, will give us our I is 2, big R is 3, Small r is 0.5, which will be 2. This is 3.5. And that will give us what? 2 times 3.5 will give us 7. That's 7 volts. And that is what? The solution for that, to find what? Electromotive force. Now let's take measurements of resistance. Measurements of resistance. There are 4 methods of measuring resistance. We have the voltmeter ammeter method. Voltmeter ammeter method. We have the potentiometer. Use potentiometer is a device. And we also have the Wheatstone bridge. And we have the what? Meter bridge. Wheatstone bridge and meter bridge. Now, on the board here is the voltmeter ammeter method. You have the connection. This is where we use the principle of Ohm's law, which states that the current passing through a metallic conductor is proportional to potential difference, provided the temperature and other physical quantities remains constant. So we say we use the principle of Ohm's law, where we have our y-axis. From the experiment, we realize that when we plot our potential difference as the y-axis, that's the vertical axis, and we have the current as what? As the horizontal axis. The slope, that the gradient of the graph formed, gives us what? The resistance in the circuit. It gives us resistance in the circuit. So there we say that what the resistance will be equal to what? Change in the potential difference over what? Change of what? Current. So from there now, we have our what? R is equal to V over I. Now, also we have what we call the what? Potentiometer. What's the potentiometer? So a potentiometer is a device used for measuring the potential difference between 2 points or 2 ends. Yes, it's potential difference from 2 points or 2 ends. It consists of uniform wire of length 100 centimeter. That's a typical meter rule. 0 to what? 100 centimeter. That's the one we use in laboratory. Now, what is the with wire stretched on the wooden side of a meter rule? The wire have a very low temperature of coefficients of resistance, very low temperature. So we say that what from there we determine our potential difference using that. Where this E is our electromotive force, E1 and E2, and our L is what? Length of the wire. Length of the wire. So we use this as a formula. This is a formula for potentiometer. Yes, let's have that formula upstairs. It will still be applicable in our subsequent question. So that is that voltmeter method, potentiometer method. Now let's take Wheatstone bridge and meter bridge. Now this is the meter bridge. This is circuit representation of the meter bridge. It consists of a long wire and 2 standard resistors. And this is a galvanometer, which I said is for measuring very small amount of current, to measure to detect current and measure the slight change of current. So we say that what this our R is the known resistor, while this is the unknown resistor. We have this as the battery. So on this using our meter bridge now, we apply this formula. R over S equals to L1 over L2, or we say X over L equal to what? R over 100 minus what? Minus L. Our X here is seen to be the unknown resistor, and this is what? The known resistor. This is length, or this is length here, that's our L1, and this side because our L2. So our 100 minus L is still equivalent to what? It's still equivalent to L2. So that is that. Those formulas we apply as time goes on. Now we also have the Wheatstone bridge. The Wheatstone bridge is connected in this form. Wheatstone bridge now, to find resistance using the Wheatstone bridge, we use R1 over R2 equals to what? R3 over R4. So we apply this to find what? Our resistance in the Wheatstone bridge, using Wheatstone bridge. So this is measurement of resistance. We've had the formulas given based on the way it's about to be measured. We discussed about voltmeter meter method. We talked about the potentiometer. We talked about the meter bridge where we apply this. With potentiometer, we said we use E1 over E2 equal to L1 over L2. Voltmeter meter method, we said we use V equal to R, and we also have our what Wheatstone bridge, where we said R over R1 equal to R3 over R4. We continue for that when next we meet, where we take in another segment of electricity. I name myself Ali Vitosin. Thank you.